Hi, I'm Jadi and welcome back to Geeking with Jadi. We are going forward on LPIC 1 and not only going forward, but we are finishing it. 109, then we will have 110 and it will be done. Here we are speaking about the basic network troubleshooting. It's very important. You should be able to troubleshoot your network for sure. If it's not working, you cannot say it's working on my computer. You are not a programmer. You are a system admin, and if your server doesn't connect to the internet or the server you need to connect to, you should be able to solve it, or at least show enough proof that it's not my problem. It's networks team's problem. And in most cases, it is. Here, I will talk a little bit about routing and everything, but in general, we are checking our own computer and not the network and connectivity in the network. Although we should be able to collect enough data to show to the network team, I'm not sure what is this, that what they should check. We will have commands like IP and hostname, which you already know about. Also ifconfig, ssping, ping version 6, traceroute version 6, tracepath version 6, netcat, netstat, and route. Note that some of these commands do have a version 6 equivalent. Same with traceroute, same with tracepath. Because in the older days, ping was working only with IP version 4. So we had ping 6 which worked on IP version 6. Nowadays, most executables understand both. And based off the data you give them, for example, if you say ping 4224, this is a very common server to try pinging. It's the DNS server, and many people use it when they want to check their connectivity toward the internet. The ping will know that this is IP version 4. And if you say ping : 1, they will know that you are pinging an IP version 6. This is like a local host in IP version 6, equivalent to in version 4. So nowadays it's not a big deal, but still we have ping 6, although ping can ping version 6 too. The reason is in some scripts you may have ping 6, so your computer should understand these commands. I will show you later. Anyway, a quick review on the networking. We had a computer in previous sessions. We assigned an IP address and subnet mask to it. For example, IP address was 168.0.101, and your subnet mask was 225.225.225.0, which is equivalent to /24 in CIDR notation. What this mean? This is your sub network. So your computer will reach any other computer in the same network which has 192.168.0 whatever, because this is 0 and you are part of this subnet. So you can reach all of these computers just by connecting them directly. But what happens if you want to go to 4224? This is your network. This is the internet, which is smaller than your network in this schematic. You want to reach this, and this is not in your subnet. So you have one more configuration. It is called default gateway or your default route. This tells your computer if you wanted to reach something which was not in your subnet and you had no clue how to reach it, just contact your default gateway. For example, in a network like this, my default gateway might be 192.168.0.1. It's a custom to call it 1, but it can be anything. You set this as your default gateway in your network configurations. So when you want to reach this is not in your subnet and you don't have a clue how to go there. So you just contact a device with this IP address and tell it, I want to ping this. You will tell this is configured to contact your ISP. Your ISP has a router which says, okay, this 422 is in this network. I will contact their router. They will tell to the server, oh, someone is pinging you. He will answer back, she will answer back, this will answer back, and you will get your answer back. This is why we have also the default gateway in our routing. So when we have an issue in our computer, for example, oh, I cannot reach google.com. What should I do? If it's me, my first step would be, not me, but let's speak in some steps. I will check if IP and network and netmask is configured. If I have a default route. If I can ping my default gateway, because you should be able to reach your default gateway, right? I will try to ping this. Then I will try to ping 4224 to see if I can reach to the internet. Then I will try to ping google.com to see if I can reach google.com. Any of these steps may have an issue. I said not me, because if it was me, my first step was trying something in the middle, trying to ping 4224. If it works, it means all of these are working fine. If not, I would go and check this. We already covered ifconfig and IP in the previous section. Please remember, ifconfig is an older command. IP is the new one. I had a comment which said, oh, why are you speaking about ifconfig? Nobody uses it anymore. I'm speaking about it because it's in LPIC and you should know it. Other than that, there are lots and lots and lots of very important servers doing the most important things in the world which do not have the IP. Our laptops might be running on the latest Linux, but most of the world servers, especially the important ones which nobody has to update, courage to update, still using this one. They might be running on Red Hat 6, Debian 9, and other very, very, very old, obsolete versions. Not a good idea to run on something which is not even get security updates, but this is the real life. So you may encounter lots of computers, especially important servers, which are running on this. And you may encounter lots of IP, and for sure you will see IP more and more and more. You should know both. We had IP ADDR show, which showed us the IP address. So for example, here I say I have one device, this is the one, and I have this IP address set on it. We also had IP link show, which showed us the more lower level networking. And we have ifconfig like this. We've seen this in the previous section and I won't talk about it much more. One important thing is you always know that you can get help by using man. So you can say man ifconfig and get all the possible things you can do with ifconfig. The point is IP is a very, very, very big command. So if you go with man IP, you will get lots of things. So if you want to get information about, for example, routing, you can say man IP-route and it will show you only the routing information. This makes life a little bit easier. So you know IP and ifconfig in general. Your computer do have a IP address. Let's check it. IP ADDR show. My computer do have a Ethernet card. It has a IP, and this is the IP, this is the netmask. So I can see every computer with 192.168.70, whatever, in my own network, physical network. Let's try it. I am 2, so this is me. I can ping myself. Very cool. What ping does? As I briefly showed you, This is your computer. You want to check the connectivity with a server, for example, 1224. You do a ping 4224. This creates a packet which is called ICMP packet, sends this to this server. Now you know a little bit about routing, so if my computer doesn't know what it should do with this, we'll send this to its default gateway. Default gateway will send it over the network to next hop, till you reach this. This computer sees, okay, I've got an ICMP packet from this address. Will answer you back. You are sending a ping, the answer to poing. And you will get back from all these servers your packet. You will get it here, and your computer say, okay, I send a ping. I got the answer in this specific time. Let's try it. If you go with 442, it says, okay, I am pinging this server. This is the size of the ping I'm sending, the packet. This is the sequence 1. Time to leave is 55 hops. So server to the next server to the next server till you reach your destination. This can be only 55 hops, which is huge. And this is the time it took for the packet to go and return back. This is a very, very large number. I have an issue in my network, but this should be very, very, very small. But it continues forever. You can break it with Control C and it will tell you I've sent 38 packets, 37 received. This much is your packet loss, which is not good. It should be 0. And this is your average time. This is very huge. It takes 3.7 seconds. This should be less than a very, very, very less. Not less than a second. This should be less than a, I don't know, hundreds of seconds. But I have a bad network anyway. On Windows, I believe it just tries for 4 pings and finishes it by itself. You can also try the ping version 6 and say ping this machine. This is the equivalent of this machine. Same thing happens, it pings this one. You cannot ping 442 using ping 6 because you are telling it I need version 6. So it will tell you this is not a correct address family. But you can use just the ping for this one and it will work. The reason is which ping 6. This is my ping 6. If I say lsltrh ping 6 or type this, it says practically ping 6 is ping 6. Okay. But it's a short link to the ping. Sends ICMP echo request. You send echo request, you get echo answer. Anyway, so this is the ping command. Please note that you have lots of configurations on the ping. For example, you can say version 4 only, version 6 only, audible ping. Whenever ping works, make a sound. Bang, bang, bang. This is so cool. Try it if it works on your computer. Sometimes the voice is not working on your terminal. But if this works, the good point is you want to check something in the network, you run the ping-a, your gateway. It's not creating any voice because it's not working. You have an issue in your cable. Then you go and fix your cable. As soon as it is fixed, you can hear the sound ping, 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 which is so cool. Another fun thing is -i for interval. Oh no, sorry. -i. Not the capital I. -i interval. How many seconds should I wait between each ping? Sometimes we connect to a server. We want to keep it connected. So we want some transmission every 10 seconds. So the server won't drop us. We would say ping every other 10 seconds. Don't just send. Some people use it as an attack and say, okay, wait only this much send thousands of pings. I'm sending lots of pings and putting pressure on the servers. If it's a bad server, it might stop answering to other requests. Although don't try this very bravely in your network, some system admins might block you, or automatically you might be blocked because you are obviously attacking a target. Another good option is this one. Now we are sending only 64 bytes. Whenever you have an issue on your computer, you have a new project, they say, okay, this is your server, please install this and run this. You need to connect to this server using your program. Because you are running a program, it gets, for example, see a request from here, sends the bill to this server and the answer to this server, but you cannot connect to this one. So the first thing you do, you ping this IP address of this server. If you can't ping it, you will tell your network manager, your network team, that I cannot ping this one. Can you please help me? They would ask, are you able to ping your gateway? You say, yes, I tried pinging my gateway. It's working fine, but I'm not reaching this one. You say, okay, we define the route here, so you will be able to reach this from this gateway, for example. But sometimes you can ping, but it's not very stable. Because when you are using normal ping, it only sends 64 bytes, which is very small. What happens if you send 10 kilobytes? You can create larger ICMP packet for better tests. You can have -s packet size, for example, and other stuff. Lots of things, which we are not going to cover all of them here, but ping is the best tool and the most basic and very powerful tool you have for network troubleshooting. Another problem you may see is pinging google.com doesn't work. So you ping 4224, which is a very common and well-known server in the internet. It works, but when you go over google.com, it doesn't work. So you can reach the internet, but you can reach google.com. Maybe your computer doesn't know what's the IP address of Google. Maybe it's a DNS issue. This is very, very common. There is a common joke in the internet which says this is the DNS issue. In many cases, it's a DNS issue. You remember, we had resolve.conf, which was our DNS. If I VI this and sudo VI this, for example, remove this completely, I will be able to ping the internet or a server in the internet. But if I go for google.com, I would get an error, temporary failure in name resolution. Okay, ping is telling me this, but if you were on a browser, it just fails. I would try the DNS. My clue was I were able to reach a server in the internet, but not resolve the Google name. So now it should work again. First, I will contact the DNS, will ask about the IP address of the Google, then I will ping it. And also have a look at this. This is called DNS was converting Google to this. Reverse DNS is converting this to this. So when ping wants to show a better, nicer, more cool result, does a reverse DNS on this IP and shows me this, because I started with google.com, so it wants to show me the human readable names. This happens in many commands. There is a switch -n in many. I'm not sure if ping has it or not. Yes, same. We say I only want numeric results. So this is the ping and ping version 6. I will speak also about the routing and routing problems, and then we will go to the next video. So you learned a bit about the routing. I told you about the concept. If you want to check it, the old command is the route. I don't have it here because it's a new Debian, but the new command is iproute. Iproute show will show you the routing table. If you omit the show, it works too. This is my routing table or routing table. It says, if someone wanted to contact 192.168.70/24. So this is the net mask. So whatever 192.168.70, whatever, just go to this device. Contact it using your Ethernet. If anyone wanted to contact 172.17, whatever, go to this network device. So my computer does have two network cards. This is a virtual one for Docker, but anyway, if someone wanted to contact this network card. If someone wanted to go here, contact this network card. But default is via this one. If you didn't know what to do, my default gateway is this IP via this network card. So this is my home's wireless router. Because it's a virtual machine, technically it's wireless, but it's shown here as an Ethernet. But 192.168.71 is this. I am 2. So if you didn't know what to do, my default gateway is this one. If I try to ping 4224, my computer will go to this table. We'll see, okay, it's not here, so I don't know what to do. It's not here, so omit this one. Oh, my default route is this one. Just send it to this machine. This will know how to contact the next one. This is a router, so it knows where to contact. A router in my ISP will contact the next hop. It will send it to the next hop. I will reach the server, the network which this lives in, and it will provide the latest address 4224, and the whole thing will go back and will reach me here. This is how routing works and how routing tables work. Most of the time I have some routes and I have a default gateway. If you didn't know what to do, do this. So if I'm pinging 4224, this is what happens. It goes through this one and will reach this one. If I ping this one is being used because I have said if something is in this network, 70/24, which means whatever here, go to this network card. One thing which you should always check is if you can see your gateway. I've told you, you have your IP on your computer, you had your net mask, and you have your default gateway or default route. You should be able to ping this without any routing, specific routing. So when you have this default route, you will be able to contact this. This is another test which we always do. If we have a network problem in a complex network or non-complex network, we always try to reach our default gateway, which is provided by IP team. These are provided by IP team. If we cannot ping this, there is a problem, huge problem. We have to go back to them and ask. If I can ping this in a project, but I cannot reach the destination server, I can tell my IP team, I can reach my default gateway, but I cannot reach this. Please solve this. They will go try to ping this from the default gateway. They will solve this problem, most probably by adding a static route here, and the problem will be solved. So this is how IP route works. You can do different things. I can even delete my IP route. I can say IP route delete default, maybe. Worked. Now the default route is not there. If I try to ping 4224, it says network unreachable. Don't even try, because it looks here, not this one, so it's unreachable. I don't have any route to go to this. I can create a specific route for this called static routes. So I can say IP route add, for sure I need sudo because I'm changing routing table. Route add 4224 via saying add a route 4224 via this one. If someone wanted to go to this, go through this. IP route, show. It says, okay, 4224 via this one. The ping 4224. It works because it knows that, okay, 4224 should be delivered via this one. But still I cannot ping another famous server in the internet, which is this one. Because it doesn't know how to go here. I only gave it this clue. Also, I won't be able to ping yahoo.com because my DNS doesn't work. My DNS will try to contact my DNS server, it won't work. So, to solve this, I have to add the default route again. Sudo route add default via sudo route add sudo route default maybe. It says route sudo route add default usage sudo IP route. Wow. Because route is also a command. I thought I don't have route. Okay, sudo has route. Route is the older command. So sudo IP route add default via this one. And now I can ping whatever I want. Because if the computer doesn't know it, it goes through this default gateway. And the last thing for this section, sorry if it's long, but I've tried to speak a little bit more than what is needed for LPIC, because this is very important when you are doing actual jobs. The last thing are tracepath and TraceRoute. It traces the path or traces the route. I've told you, when I am pinging 4224, I'm contacting my default gateway. My default gateway contacting the ISP. It may contact the router in my ISP. It will deliver the packet to a general internet. And this might contact the network which hosts this. Another router can do this, and we will go all the way back, and this reaches me. When I do a ping, I just send an ICMP packet from here. This receives it, answer back with a pong. I will say, okay, I received it. I won't see any of this. But when you are doing a trace route, your computer will show you all the steps it is taking to reach there. So my computer is saying, I'm contacting my default gateway. Took this much. I'm contacting this one because this is what my default gateway showed me. Practically, this is going step by step. Technically, this is a little bit more complex, but reading the result is very joyful and easy. It says, okay, I'm taking these steps. This is the first hop. This is the second hop, internal network and internal network. Then I went to this IP address. There was a server which didn't show its IP here. Next hop was this one. I've reached this IP address. Then I reached this IP address and I was able to reverse lookup it to Bell Canada in Vancouver. Then Bell Canada, Seattle. It's just the name of the servers, not the locations. This was the IP address. It routed me to level 3 Seattle, level 3.net San Jose, and this IP address, and here I reached this on resolvers level 3.net. These are the steps I took to reach this. People love TraceRoute, and if you are contacting a network team to tell them I have a problem reaching a destination, it's very cool to include your TraceRoute. If it's not working somewhere, you may see only the stars for some time and then a break. It's finished without reaching this. Or anything, any other condition. You may see different things. But if that's the case, your network team will know that you are passing this and you've reached here. From here, it's not working. The administrator here will check why I cannot reach here from here and will resolve it for you. Another command is tracepath, very close to traceroute. I don't have it installed here. Technically, they have some small differences on the implementation level, but for LPIC, they are the same for us. And also you have version 6 of both. So you can have this, which says, okay, this is not a version 6 IP. So I'm not going to do this. And if you are trace routing to yourself, it says, okay, first hop is myself, done. So we had 4 more commands: tracepath, traceroute, tracepath version 6, traceroute 6. They are highly similar for us. And you saw the reverse, and you know that this means this server is blocking ICMP traffic and doesn't revealing its identity. Sometimes they do this for security reasons. Sometimes even network administrators block the ICMP totally, which is not a good practice in my idea, because ICMP is there for a reason, and the reason is being able to troubleshoot. You cannot block all the doors with cement and say, okay, now the whole house is secure. Let's go to the next video and speak about SS Netestat and some other tools.